nums of I can be positive, 0 or negative. Again, that's a plus factor. Number can be 0. Number can be negative also. If it would have been only positive, I would have said it's exactly same as having a 0, 1. But it's having a 0 also. Okay, Aryan, what's the difference? No worries. No worries at all. There's no difference at all. Let's see how we'll solve it. Again, we'll come back to a very basic thing. It just simply asks to return me total number of subarrays whose sum. So I'll do exact same stuff. I have an array. I will find total number of subarrays. My total number of subarrays are n square, and then I will find the sum of those subarrays, which is again O of n time. So it will become O of n cube. The one basic brute force approach I can tell my interviewer, method 1 is okay. Approach 1 is simple brute force. Now, a bit optimized brute force. We have usually seen that if we have a subarray, again, we used to split it, okay. Firstly, find the subarray and then find the sum of that subarray. But I can just club them up, which means while finding my subarrays, which are O of n square, I can parallelly compute the sum also of that subarray. How you can do it? For example, while you are moving your pointers, I and j pointers, you make sure, okay, I pointer, j pointer, I pointer, j pointer, I pointer, j pointer. So I'm saying, as you have your I and j, okay, right now your sum will be 1. Okay, add a 1. By default, your sum is 0. Add a 1 as soon as you are at j. As you move on your j, again, for this specific subarray, the sum is 1 also, and that's true. As you move on your j, earlier, because of the basic brute force approach, you had to go on to the entire subarray. But now I'm saying just simply add the component of j, which means I'll only add my sum of 2. So now in the existing sum, which was 1, I added a 2, it became sum of 3. So with this, easily you can get a subarray sum I to j. Again, as you move on your j, only add the jth component. So you will get the subarray sum from I to j. And that's how you can optimize it and get, for all these subarrays, the subarray sum parallelly in O of n square time also. Okay, but still, by the constraints, still it will not work. For me, like neither for this nor for other problem. Again, on the right side, I have 560. On the left side, I have what's the problem? 930. Now, coming on back, that how to actually improvise it. No worries. Always read the problem statement. Problem statement simply says one thing. Bro, return me the total number of subarrays whose sum. So ultimately, I am saying I have to find the subarray sum, which means I have to find, again, subarray is a portion of an array. So I have to find the range, which means in a specific range, I have to find the sum. So ultimately, my problem boils down to finding the range sum. Now, we have a few algorithms. Okay, we have sparse tables, we have Fenwick tree, segment tree, but the basic, most basic range sum algorithm is prefix sum for us. Now, if you don't know what's a prefix sum, no worries, I'll give you a quick glance, but you should be knowing what a prefix sum is because it's very important. So prefix sum simply says, okay, keep the track. Again, Aryan, how would I know that I have to use a prefix sum or a sparse? For sure, sparse table you have not even studied, and there's a high chance that you will not even study if you're considering only DSA. If you want CP, I'll highly recommend. It's a very short, crisp, sweet algorithm. Now, coming on back, how would I know? Okay, if you don't have any updates, and it's very simple. You just have to do a pre-computation and then find the prefix sum or find the range sum. Then for sure, prefix sum is the best approach to find the range sum if you don't have any updates at all. Now, the prefix sum simply says one thing. Keep track and say, okay, my so far, again, prefix as in the starting part, sum. Starting part sum is the prefix sum, which means 1, 1, 2, which is the sum is 3. Okay, 1, 2, 3. The sum is 6. So it is how I'm keeping track. So by default, initially the sum is nothing, 0. Then I added a 1, which means my sum became a 1. Then I added a 1, 2. Then it became a 3. And then I added 1, 2, 3. It became a 6. And Aryan, so to compute this, I have to get the entire array sum. Bro, no bro. Simply add this to get a this. Simply add this to get a this. That's how you can simply compute your prefix sum. Which means prefix sum of I, let's say I am at I, it will be nothing but prefix sum of I minus 1, which is this value, plus your nums of I, which is this value, nums of I. That's how you can simply compute a prefix sum array in O of n time. Okay, Aryan, when it is done, how are you saying that it can give me the range sum? Bro, if I ask you that you want to find the range sum from here to here, then you can simply say, okay, prefix sum of 6 minus prefix sum of 1. Aryan, I is here, j is here. So you are saying that prefix sum of j minus prefix sum of I minus 1 is the answer. Yes, bro. That's how you compute the prefix sum. You can see 6 minus 1 is 5, and you can see the range sum is 5. If I ask you, oh, any other range, let's say if I ask you the sum of this range, j is here, I is here. So my answer will be j minus I minus 1. Prefix sum of j, prefix sum of j minus prefix sum of I minus 1. That's my range sum. Okay, 3 minus 0. That's the range sum, which is 3. Okay, so far you have got that. Okay, you can easily figure out range sum, which is the subarray sum, in O of one time by doing a pre-computation by using a prefix sum. So now you have got to know that, okay, your ultimate maqsad kabhi nahi bolna. Your ultimate maqsad is that you have to find goal. Or are you not? I know goal. Oh yeah, bro, you know goal. And also you are at, again, if you're moving in, you can move in any indexes. Okay, as if I am moving in, I will be having my j. Okay, imagine, okay, usually you move via I, but as you saw, my I is before j, so something after should be moving, right? So let's say my j is moving, okay, which means if my j is moving, I am at my j pointer. So I know what is nums of j, and I also know what is prefix of j, because I have pre-computed this. So I know my goal, which is given in the question. I am moving on my j, so I know the prefix of j. I know this because I am at this right now. This is given to me. I have to just simply figure out what is my prefix of I minus 1. No, Aryan, you don't have to figure out what is prefix of I minus 1, because you already know. Because see, prefix of I minus 1 will simply be prefix of j minus goal. This is what you know. Your ultimate maqsad. Your maqsad was that you have to find out number of, again, remember, maqsad nahi bola. Your ultimate aim was number of subarrays whose sum. So I don't have to find, like, I can find, okay, this is the prefix sum of I minus 1 which I require, but I wanted number of those. So I'm just saying I wanted how many of those prefix sums are actually available. How many, as in frequency. Okay, I need the frequency to be there. So what I'll do, I will maintain the frequency of what? Prefix sums. So I will have to maintain the frequency of prefix sums. So okay, if let's say I know this is the prefix sum of I minus 1 value, which I need to figure out how many such prefix sum of I minus 1 are there, these many number of subarrays will be there. For example, let's say this was our nums. I simply computed my prefix sum quickly. You can simply see quickly. Again, these examples are built by me just because in the future I will tell you something great, and that's the reason I had to build a bit examples from my end. Now, goal is 2. Okay, great. Simply, you will say, bro, if Aryan, I am at this specific index j, I need to know, okay, j is this. So I know the prefix sum of j is this. So what will be the prefix sum of I minus 1 value, which I need to find? This value. What will be this value? This value I know, again, it is equal to this value. I know it is 2. Goal value was 2. So ultimately I'm trying to find prefix sum of I minus 1 as a 0. So I'm saying, okay, if I am at this specific j, I want to find 0. But remember, frequency of 0. So how many zeros have occurred previously? 2. 2 zeros have occurred previously, which ultimately indicates us that, okay, I will have 2 subarrays. I will have these 2 subarrays. And that's how you can simply keep on accumulating your prefix sum frequency. Again, firstly you will compute the prefix sum, then, or you can do everything parallelly also. Compute prefix sum parallelly, compute the frequency of them also parallelly. I'll show you guys that. But yeah, if a basic approach you want to take, simply compute the prefix sum, then iterate on the array again, and then as you keep on moving, keep on keeping track of the prefix sum frequency, and then update your actually, okay, at this specific j, what is the frequency of prefix sum of I minus 1 which I require, and that many number of subarrays will actually be ending at jth index. Cool. The code, again, it's pretty simple. Again, if you want to do a bit more dry run, you can do it, but I don't think so, because it's a simple concept of prefix sum which I have explained above, and then accumulating that with the concept of frequency. That's the major 2 concept which we will actually club with each other. So again, I will do it everything together, which means I will compute the prefix sum also parallelly, and also I will be computing my frequency also parallelly. So I had my prefix sum array. Okay, great. I don't know, there's one thing I saw today in Leetcode, that some variables colors was being changed. I don't know what's a bug, but yeah, that's a bug. Comment down below what you think could have been the bug in this case. Now, here I keep track of the frequency. That frequency will be of prefix sums. Now, you will see that in the very beginning, you always have a 0. So frequency, again, frequency of 0 will be 1, because 0 is always there. Now, I'll keep on going on to all the elements of my num. As I land on to any element, again, increase the prefix sum value. As you increase the prefix sum value, okay, that's done, that's great. But as soon as you are at any specific prefix sum value, you have to go and find your prefix sum of I minus 1. So I'll go and just check, okay, bro, prefix sum of I minus 1, that is nothing but, that again, that is nothing but current prefix sum minus goal. Current prefix sum minus goal is the value which I am looking for, and that from that I'll grab the frequency. So I'll search in my frequency unordered map that prefix sum minus goal. Again, this prefix sum is prefix sum of j, which I was referring, because I am moving on to my j. This is for j. Again, I don't have to make a new array. That's the reason I took as a variable, right? Okay, to reduce a bit space. Space will not reduce, like space complexity will still be open, but a bit space will be reduced by this. Now, I will simply go and find it. If it is there, great bro, great. If it's there, then your frequency of how many times this value was there, I will add that many number of times in my answer, because that many number of sub arrays will be there. Okay, then ultimately when this portion is done, which means the contribution of these zeros are added, then okay bro, for the future purposes, this frequency needs to be increased for this specific 2. So I just said frequency of this prefix sum of j, increase it by 1, because okay, I have encountered a 2, which is the prefix sum value. So exact same stuff, frequency of prefix sum, increase that by 1, and that's how you're going to simply iterate and return back your answer in simply O of n time, because you will see it's a simple O of n operation. Everything is a O of n operation which is happening, this loop I am saying. Now again, this find is a O of n operation in an unordered map, because we are using an unordered map, which is a simple hash map. So you saw the time we are using is O of n, but the space we are actually using is, because of frequency, we are using a space also of O of n. Although we reduce the space by not making a prefix sum array, but still indirectly we are making or using a space of O of n. Now you might say, Aryan, this is the best case. For sure. Again, the exact same code will work for our this 560, which has been asked by so many companies. It will exactly work. And you will be shocked to hear this is the best possible solution for your 560 problem. Best possible solution. Now, coming on back, Aryan, why you specifically said the best possible solution for 560 problem? Is this not the best for this problem? This problem, is it not the best? Like, did you ever think of one thing? I never considered what could have been the value between these. I never considered in this, like in any point of time I ever asked you what could have been the value. Is it matter, like will it matter or not? I never asked you. So now to think of that, again the interviewer will say, can you please improvise it? Now you are just shocked how you will improvise it. No worries, go back to the example. So again, that method 4 is danger for the folks. Again, people on the YouTube and other stuff, they will just teach you. They will just teach you, but it's a danger if you don't understand this, how things work, how 2 pointers, how other, again I'll not tell, okay, I have already spoiled, but yeah, if you don't know how 2 pointers, sliding window, all that stuff works, you will end up wasting your time both in contest and also in an interview. So your basics should be clear that okay, when what to apply. That's what we're going to see now. So again, that's a danger for those who don't know and they end up applying anything. So what happened in this case, we saw that we simply had to find the goal of 2. So we saw that okay, we have a simple array, then I can simply expand this. Oh, expand this. Can you just remember something? Expand, then shrink, and then you will see, okay, I just simply shifted this, then I shrinked this. Did you, like, can you just recall of something? Okay, you have a window in which you expand the window, you shift the window, you shrink the window. Oh, that seems like a 2 pointer and a sliding window. Again, both can be used interchangeably because it's a window and the window actually works on pointers. So both can actually be used, but I will say, let's say 2 pointers or sliding window, I can use both of them. Both of them mean same. So okay, that's a window. Again, sliding window is more of the window remains same, but 2 pointers says windows can be shrinked or increased. So now we can easily see, okay, Aryan, I can see something. I can use 2 pointers and I can say, okay, this is the window for me. This is the beginning window for me. Again, let's erase it. This is the beginning window for me. I is here, J is here. I know that in my 2 pointers or in a sliding window, I keep on increasing my J. Again, that's a standard concept that if you had to use a sliding window or 2 pointer, So either you increase your j at every step, and then you can keep on shrinking your I, so that you can actually see how many number of such subarrays are there. So maybe I know that, okay, I still have the capability to increase my j, so I'll have my I here and j here. Okay, then I try to increase my j again, but then my sum became a 3. That's a pain for me. It should not. So I'll just try to shrink. Okay, if I try to shrink, then my array will become I and j like this. Again, j is ended, so for sure you will try to again maybe shrink. Okay, again maybe shrink, then I and j became like this. Now, so far people are really thinking, okay, Aryan, I got it. It's a sliding window. I simply apply it. Bro, you missed a lot of things. There are many stuff happening here, and you should be knowing when and what to apply. Although I have told numerous times on the videos that when to use 2 pointers, or maybe like I cannot, again, I'm actually using a sliding window here, but again, remember, sliding window is saying the concept that the window remains same. You just keep on moving. 2 pointers say, okay, window can shrink, expand, all that stuff. Usually sliding window concept is more used in, let's say, Rab and Carp, building hash and stuff. Sliding window is more of window remains same, but 2 pointers, window can shrink, expand. But both of them cannot happen simultaneously. It means shrinking, then shrinking, expanding. That's not sliding window. Then it's a simple 2 pointer. Sorry, then it's a simple loop for you happening. Now, coming on back, that I have already told that in a 2 pointers, how we usually think of is, okay, if things are increasing, again, when I say things, I mean it can be either array, it can be either sum. It is what you want to find the answer for, or maybe it's a hop in between. For example, I'm just thinking of a number. I just want to apply 2 pointers on my number. Maybe the numbers are increasing. Maybe I want to find the sum of them. For example, in this case, maybe the sum is increasing. Maybe the sum decreases and then decreases from the end. So maybe it is decreasing and then increasing. So in the cases when your thing, it increases or decreases or increases, decreases, in that cases, it's highly likely that you will apply 2 pointers. Now, what you mean by thing in this case, Aryan? So you can simply see the thing, what I meant was your sum. For you, your ultimate maqsad was to find the sum. So for sum, you will see the prefix sum, as you saw also, just to say the prefix sum was 1, 3 and 6. So it is increasing. Aryan, but elements can be 0 also here. Okay, bro, that's true. It can be then same also. Like, okay, it can be 1, 1, 3 and 6. So, okay, when I say increasing, I mean non-decreasing always. Okay, right? Okay, make sure. Now, and how to use 2 pointers in these cases? Simple. We know that we have a window. Remember this fact, we have a window. I and J. J is always later on. Like, that's how I usually do it. You can also keep I later on. Now, J moves. We, to simplify stuff, usually have a template of 2 pointers that, again, that's a 2 pointers in which we are actually compressing and expanding. So while j is less than n is the size of the window, then at every step, no matter what, you will increase your j. That's a simple template. But, okay, which means we are at every step I'm increasing my j. But I'm saying that if whatsoever condition satisfies for us, that's good, I will keep on moving my j. But if some condition is not satisfying, which means in this case, this condition is sum. So if I'll keep on moving my j, sum keep on expanding. That's true, it will. But as soon as it becomes more, I have to start shrinking stuff. So it is a simple case that while your any condition, here in this case, it was the sum. If the sum becomes more than the goal, then bro, please keep on shrinking, which means you will just keep on bringing your I. This is a basic template which we use for expanding and shrinking, which is usually 2 pointers which we use. Now, in this case, you can simply see that your j always increases and then your I moves when you actually have to improve, like decrease or increase your thing. Again, I'm using a thing word, not the actual thing, because it is generic. So I'm just saying expand I and compress, expand j and compress I. Expand j, compress I. I is compressing my window, j is expanding my window. And this to be simplified, again, you can actually implement it in many other ways, but just to be on the safe side and just to build a template out that if we didn't have to apply our minds much, we just usually have a template that, okay, at every step my j will increase, and on the basis of the condition that, okay, if my condition has violated, which was the sum for us, if it has violated, then okay, please increase, or basically please compress your I. Now, for sure, we will, again, that's most important problem is for us is 560, which was having that the elements can be negative also. Because it has been happened so many companies. So that's so it's a prior problem for us, like priority. So what I will do is I will just try to think, okay, bro, let's try this sliding window, because okay, it's a sliding window, which means okay, it's just using 2 pointers. So for sure I can optimize my space. I remembered my space was being used as O of n. Time will for sure be O of n. It can never be reduced, but still maybe space can be reduced. So I might end up thinking I will apply 2 pointers here. That's great, Aryan. But you know the hint. I told you it's not be applied. Let's see why I was saying that. Again, that's for when I had negative elements also. So what will happen in this is that you have your I, you have your j. Again, I just took any middle, okay? Currently your state is I and j. Now, your current sum is 1. You can see -1 plus 1 plus 1. It's 1. Now, if I ask you, bro, you are saying, okay, if I go by your template, Aryan, if I go by your template, you will say at every step j will increase. Okay, and then if your sum becomes more, then your, like, you will say, okay, your I will actually increase, which means you will compress. Okay, but in that case it was fixed that my j will increase. Okay, then my sum becomes more, then I will compress my I. Okay, here you will see my even if currently my sum is 1 for sure, which is less than my goal. So you might end up thinking, Aryan, for sure, it is less. So it is obvious that I will increase my j. So what you might end up happening is that, okay, your I is still here, you will increase your j. Aryan, you can see my sum increased. Now my sum is nothing but 3. Sum increased with j, and that's what was happening also. Okay, bro, great. Then you might end up saying, okay, my goal was 2, so I will just end up decreasing my I. I might end up decreasing my I, which means increasing my I, which means compressing my I. So if you compress your I, okay, compressing your I, you see what happened. Your sum earlier was a 3. Now your sum became a 4. Compressing your I increased your sum. Oh, Aryan, which means Aryan, maybe it is a case because I was compressing wrongly. So what I will do is I will compress first. Earlier you were saying, okay, expand, always put the j. That was what you were doing. So maybe I will just go reverse. What I will do is, I know this is a window, so I just want one thing. Okay, I know one thing, that maybe after compressing my window, like my sum will increase. So I just compressed. Okay, now my I is here, and now as you can see my sum also increased. It has become a 2. Walla. You will end up increasing your I, just in the case you are thinking maybe your sum will increase now. But what if it is -1? You increase your I, your sum will again decrease. So now it is super like confusing that, okay, you should shrink or you should expand, because in expanding also you can increase your sum or decrease your sum. In shrinking also you can increase your sum or decrease your sum. So it's a bit, both are confusing, that is it good to expand or it is bad to expand or shrink. Anyways, both will cause confusion. So no way I will end up in a confusion. Okay, I should expand, shrink, expand, shrink, expand, shrink, expand, shrink, expand, shrink. Both on I and j, anything can happen on both sides. So it's of no point. I will end up having a O of n square algorithm if I use sliding window in this. So you saw that I cannot use, again, just to give you a summary, because of negative numbers, I got to know that my sum will actually end up decreasing or increasing, It can go anyways. As soon as I move my I or j, anyways, the sum can either increase or decrease. That's the reason I cannot apply my 2 pointers, because I know my graph, it cannot go like this. It should be consistent. So if my sum will decrease, increase, then for sure I can never apply my 2 pointers. So I got to know that because of the negative number only, I cannot apply my 2 pointers here. Okay, no worries, bro. Let's come on to the existing problem, because in the existing problem, which was binary summary sum, we know the numbers are binary, so numbers are not negative. Maybe we can apply Aryan. Maybe we can apply 2 pointers here. Let's see. Again, I'll take a very normal. Again, you will see in every problem I always land onto a mid example, because I don't go from very scratch, because there's no time to go on from very scratch and then take a mid example. Always think of a mid example. I took a mid example, ij. Again, this is the example which I made. Now, my goal is 2. Okay. So now you will see, Aryan, that usually you say that, okay, always expand. Oh, bro, the goal is 2. Your sum right now is also 2. So it's good, right? It's good. It's good. It's good. So you should not increase. Rather, you should shrink, compress the window so that this will be the new window size. And this new window, again, please make sure to listen very carefully because it can be a bit confusing. So right now your window is this. Now I'm saying, considering I go by your fact, which means your instance, Aryan. If I go by Aryan's fact, Aryan always increases his j. Okay, Aryan always increases his j. So now the window size becomes this. Still my sum is 2. Oh, my sum is 2. Now I have the ability. To compress it. So I will do, okay. Now my sum is 2, which is the good sum for me. So maybe I can try compressing it. Okay, compress it. Okay, now still my sum is 2. I'll again try to compress it, but I cannot compress it. So maybe by so far I've saw, okay, if I increase my j first, then I have a chance to compress it. Then if I increase my j first, so my possible windows or possible subarrays which I will give you as an answer will be this one and this one. Remember this fact. So I will put this one and this one. Remember this fact. And again, no other subarrays was given by you to the answer. But if I had chosen to compress first, if I choose to compress, because still I know the sum is 2, my goal is 2. So maybe I can compress it right now also, right? Okay, I'll compress it first. So my answer, the answer which it gave is, it gave me is this one. Then you might end up saying, okay, Aryan, now I cannot compress, so I'll try to expand it. Okay, I'll expand it. So this one. So this is the answer which you end up giving your solution. Even if you follow my way, which is expanding first j, or if you say, okay, no, Aryan, I'll compress my I first. So you end up giving this as an answer and this as an answer. So you saw that this one, the blue or like the pink one which I highlight, okay, it is covering. But then if you shrink first, then you will get the top one. If you expand first, you will get the bottom one. And you can do one, like either you can shrink first or you can do expand first. Anything you do, one thing you will miss. Oh, which means Aryan, simple 2 pointers cannot be applied here. We have to use some other magic. And that's the reason. People just tell you, oh, it's so simple 2 pointers, apply it. Bro, it is not that simple. Now, we have got the issue, okay. If we start by shrinking, then if we start again, let's come back. Okay, let's erase this. If we start by shrinking, I here, j here. If we start by shrinking, then either my sum will remain same, my new sum. Because you saw, right now my sum was 2. If I shrink it, my sum still remains 2. Or if it would have been a 1, so if I shrink it, my sum would have become a 2. Like if right now the existing sum would have been 3, so the new sum would have been become a 2. So I saw that with shrinking, either my sum will remain same or my sum will decrease. My new sum will either remain same, which means equal, or my new sum will actually be less. And also the same will go for vice versa. That if I expand, either my sum will increase or my sum will remain same. And that's the fact. This equal to is only possible because of 0 as a number. If 0 would not have been there, we would not have to even think of any of these conditions. You have simply applied simple 2 pointers. Simple expand, simple compress. Simple expand, simple compress. That's how you would have solved it. But now it is equal to, which is causing an issue. But still, it is not that confusing as what we had previously. That because in earlier case, when we had negative numbers also, expanding or compressing anything whatsoever you do, you will end up having something different. But here in this case, I know, bro, it is either expanding or compressing, which means either my array is like this or straightforward going up, then my sum is this or going down. That's how things are working. Okay, great. So now I got to know that we can't directly deal with equal to sum. Because I know, okay, my new sum, it can be less or more. So I can indirectly deal with less than equal to sum or more than equal to sum. So I am actually dealing with less than equal to sum or more than equal to sum and not directly with equal to sum. Equal to sum I could have dealt if I had only positive numbers. So I cannot do that. I will actually have to deal with less than equal to sum. Aryan, what you mean by that is that, okay, so as to find the number of subarrays with the sum equal to goal, you will just simply go and ask, bro, give me the number of sub-arrays with the sum less than equal to goal. But you remember, you want to find equal to goal. So then you can simply subtract with the number of sub-array sum less than goal. Aryan, what do you mean by less than goal? Like, I only know for less than equal to. Bro, you can convert this less than goal to nothing but sum less than equal to goal minus 1. So this became exactly like this. It's just that goal has just reduced by 1. So I can simply make a function. Let's name the function at most. You will see why the function name as at most. But let's say I name this function. Then I can simply call, okay, nums is my input array. And now my goal is this specific goal. Again, remember, this function should return number of sub-arrays with sum less than equal to your goal. Then again, you will find and go same function with the nums and saying goal minus 1, which is nothing but less than your goal. Now, let's see how this function will work for us. Again, remember, remember the aim of the question, like aim of the specific function. Number of sub-arrays with the sum less than equal to goal. So now, right now, when your I and j are very at the beginning, you know the sum right now is 1. But answer is the number of sub-arrays less than equal to your sum. How many are there? Right now, 1 are there. Okay, this is the 1. 1 is the number of sub-arrays with the sum less than equal to your goal. And I have showed on the right side what that one sub-array is for you to know that, okay, to just help you visualize. Now, for sure, my j will move. Again, exact same concept. J will move, j will move, j will move. I will just simply compress it down. Now, okay, j will moves. Okay, j was 0, so sum will still remain same, but my answer, I'll increase by plus 2. Plus 2 is 2 more sub-arrays added with the sum whose sum is less than equal to your goal, and the 2 sub-arrays are 1 is 0 and 1 is 0, 1. Again, remember the fact 1 as the sub-array was already there. Okay, now your j will again move. Again, your j will keep on moving at every step, no worries. So your sum will increase to 2. Again, your sum is less than equal to k. So your answer will be, I'll add to plus 3. Plus 3 is saying 1, 1, 0 and 1, 0, 1. 3 sub-arrays added. 3 sub-arrays added. So again, my j will move. My sum will still remain same. Again, I'll simply add it again. Now, as I was showing you the numbers, now I showed you what I'm actually adding. I'm adding j minus I plus 1. It's simple. Okay, 0, 1, 2, 3. So I'm adding 3 minus 0 plus 1. So I'm adding 4 sub-arrays, which is 0, 1, 0, 0, 1, 0 and 1, 0, 0, 1, 0, 1, 0. These 4 I'm adding when I'm at j. So this is the number of sub-arrays which I'm adding. Now, Aryan, what if you increase your j much more? Okay, as I increase my j, my sum became a 3. As soon as you know, okay, if the sum became more, bro, do one thing, bro. Simply compress your I. Simply compress. So while my sum is more than my goal, I'll simply compress, which means reduce my sum and increase my I. And that's how compression works. And that's how you can simply apply your simple logic of 2 pointers here itself. So what will happen in the code ultimately? Firstly, you have your I, j, answer, sum, and your n. While your j is less than n, again, standard template of your simple 2 pointers. While your j is less than n, ultimately in the end, remember, increase your j. Everything will go in between. As you are specifically on the j, firstly add the contribution of j, because at every step your j is moving. Add the contribution of j. Now, what if your sum became more than your goal? Bro, simply compress the array. I'll keep on compressing the array. Make sure to also put this condition, because if you end up compressing a lot and you surpassed your I, then you will end up even increasing it. Either put in the condition that I is less than n, or put in the condition that I is less than equal to j. Like, put in anything so that your I should stop after a point. Cool. Then I'll simply decrease my sum because I'm increasing my I, and then I'll simply keep on moving, like compressing my I. Simple concept. And then answer plus is equals to j minus I plus 1, which is the contribution at the jth index number of sub-arrays which I have added at the jth index. And that sub-arrays is all these sub-arrays whose sum is less than equal to k, because after this loop, any sum I get will be the sum which is less than equal to k, less than equal to my goal, and simply ultimately return the answer. Again, I called this function firstly for my less than equal to goal, and then for my less than goal, which is nothing but less than equal to goal minus 1. So this difference will give me equal to goal value. And that's how I can simply say my time, because I'm using simple 2 pointers, my time is O of n, and space is O of 1 because I'm not using any space. But remember, this is only applicable when the numbers was positive and 0. If the number would have been negative, it is not applicable in that, because we saw it will end up giving us O of n square solution rather than O of n, which will increase our time, and that we don't want. Cool. I know this video has gone a bit long, but I wanted to make you understand how to think of, so that you don't waste your time. On YouTube, people will just tell you, do this. They will not tell you when to use the 2 pointers and when not, which will actually hamper. And you might end up thinking in an interview, oh, Aryan taught us the similar problem and I can again apply 2 pointers here also. Sorry, side note here also and 2 pointers here also. It will not be applicable. You should be knowing the basics of when to apply what. Cool. Thank you so much. Goodbye. Take care. Bye-bye. Cheers.